Hello everyone, I am Aishwarya, Assistant Professor, Department of Mathematics, Dr. SMS Rajalakshmi College of Arts and Science. And today we are going to see a topic, matrix operations. So the first one is matrix addition. Matrix addition involves adding corresponding elements of two matrices. If we have two matrices A and B with the same dimensions, the result of adding A and B, that is A plus B, is obtained by adding each element of A to the corresponding element of B. So let's see the example of matrix addition. So consider two matrices A and B. We have to add these two matrices. So for adding, we have to add the first element of the matrix A with the first element of the matrix B. Here the first element of the matrix A is 9 and the first element of the matrix B is 3. So we have to add these two values. So the same way will be followed for the remaining elements also. Then the resultant matrix is obtained, that is A plus B. And the next one is matrix subtraction. Matrix subtraction involves subtracting corresponding elements of two matrices. If we have two matrices A and B with the same dimensions, the result of subtracting B from A, that is A minus B, is obtained by subtracting each element of B from the corresponding element of A. So let's see an example of matrix subtraction. So consider two matrices A and B. We have to subtract these two matrices. For subtraction, we have to subtract the first element of matrix A to the first element of matrix B. So the first element of the matrix A is 9 and the first element of matrix B is 3. So we have to subtract these two values, that is 9 minus 3. So in the same way, we have to subtract for the remaining elements also. The resultant matrix is obtained, that is A minus B. And the next one is matrix scalar multiplication. Matrix scalar multiplication is an operation in linear algebra where each element of a matrix is multiplied by a scalar. Let's consider a matrix A and a scalar C. The result of scalar multiplication CA is obtained by multiplying each element of a matrix A by the scalar C. So let's see an example for the matrix scalar multiplication. So consider a single matrix A and we have to multiply a scalar with this matrix. So in this example, I consider a scalar as 2. So we have to find what is 2A. For calculating 2A, we have to multiply the scalar, that is 2, with the each element of the matrix A. So first I multiply the scalar. So first I am multiplying the scalar with the first element. So here the first element is 1. So then 1 into 2, which is equal to 2. Then the second element is 2. So we have to multiply the same scalar with the second element, that is 2 into 2, which is equal to 4. In the same way we have to do for the rest of the elements also. Then the resultant matrix is obtained, that is 2A. And the next one is matrix multiplication. Matrix multiplication is a fundamental operation in linear algebra where two matrices are combined to produce a new matrix. This operation involves taking the dot product of rows and columns of the matrices. Given two matrices, A with dimension n cross n and B with dimension n cross p, the resultant matrix C, that is A star B, will have a dimension m cross p. The elements of the ith row and the jth column of C is obtained by taking the dot product of the ith row of A and the jth column of B. So next we are going to see an example of matrix multiplication. So consider two matrices A and B. For matrix multiplication, we have to multiply each row with all the column. So in this example, first I consider the first row. So I multiply this first row with the first column, that is 1 into 2, which is equal to 2, plus 2 into 1 which is equal to 2. Next I multiply the same first row with the second column. Then 1 into 3 which is equal to 3 plus 2 into 2 which is equal to 4. In the same way we have to do it for the second row also. So for the second row I multiply the second row with the first column, that is 3 into 2 which is equal to 6 plus 4 into 1 which is equal to 4. Then multiply the second row with the second column, which implies 3 into 3 which is equal to 9 plus 4 into 2 which is equal to 8. So further simplification we get the resultant matrix, that is AB. Thank you.